All right, let's get some music on. Okay. Hey everyone, Lazy Ben. Start of a new week. As ever, got my giant cup of coffee. Time to finish off some world map code. Let's just cancel these changes. Or just stuff I was messing about over the weekend, but I'm not going to include that. I'm going to wipe all that stuff. Okay. So let's just look at the notes. If I can get them up. Alright. So that was week 7 that we just did. We did 6 out of 7 things. Start the world map code. New eye with navigation. Locations. Now I think we can say we did that. We did start the world map code. Okay, so that was a good week. Did quite a bit. 7 things, according to this. Okay. New week. 24th to the 28th. So week 8. 24, 28, March 2025. So this week, so it's, we want to, so this week is about the monorail really. So the space station's going to have a monorail on it that you'll be able to travel around on and look at all your nice gardens that you've made, because it is a gardening game. And it's just going to be a bit of a chill part of the game really. And maybe so you could just jump on it and then drive around. I don't think the player's going to be able to drive around. I think the monorail's going to drive itself around. Or you can maybe select a station and fast travel to the monorail station. So it will be a second form of fast travel as well. Okay. So the goals for this week are going to be complete first. So there's a few things we need to tie up first. First pass of fast travel. So we need to think about what we want to do to complete that first pass of fast travel, because we're nearly there, but there's a couple of things. I want to be able to discover the locations, definitely. And there might be more things. So complete first pass of world map. Because right now we're drawing the world map. We're drawing the world map kind of in the actual. We're drawing it in level, but we need to draw it on the world map UI. And we're not quite finished drawing it yet. Even in the level, we need to finish that off. Complete the first pass of the world map and then start the monorail system. Three goals. The monorail system. No idea really how that's going to work, so we're going to put start it. I don't think we'll be able to finish it this week. I don't think I'll know if we'll be able to finish this week until I know how big the system's really going to end up being. So we're going to say start it. Okay. Right then, that's good goals for this week, I think. All right. So where did we get to last week? I believe we had the world map. We were doing this, pushing the rooms of the world map apart so they don't overlap. So we need to find. So this is what's happening. They're getting pushed apart. So there's a room here that's overlapping this room. There's 2 rooms here, and this is getting pushed apart. Whoops. This is getting pushed apart, and that's in turn having to push this room out of the way. So this becomes the final world map. So it does look a bit weird because it looks like this room's connected to this room, which is connected to this room, which is not actually true. This room is connected to this room through these rectangle outlines. So I think the first thing I want to do is just draw the connections. So we have a connector bounds. We should have a source room and a desk room. It has a source and a desk connector. So we just need to draw a line. Okay, so auto source con bounds is that. And then auto desk con bounds is that. And then I'm just going to draw a line which connects them. So line in world. The first point is the source con bounds dot center, and the second point is the desk con bounds dot center. And we'll just draw it like fuchsia color for now. And that will just show the connecting rooms, or how the rooms are connected. There we go. So you can see we've got this fuchsia line connecting the rooms together. Okay. So what we want to do is we don't want to do this every frame. This is what we were doing just to render the debug output. What we want to do is we want to do this many times. We want to do this many times in one frame. So let's just see if we catch this intersecting variable. It's detecting when no rooms are intersecting, which we know, if that happens, we know that we've solved it. So look down here just for this output. So it should say they are intersecting for a long time. So true, 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 and then eventually it should end up being false. All right, now it's false. So we are detecting. So what we want to do is this needs to just iterate while it's intersecting. So let's just see. Let's just see if this should solve it immediately now. Either that or an infinite loop. Okay, so it just solves it immediately. And what happens if we can't solve it? That is the question. Now, this is going to be an offline process, so it's never going to happen on the player's computer, which means we'll never lock the game up. We'll just end up locking the level compiler up. This is going to happen, probably the world compiler, because this is probably going to happen in the world builder, the world generator. But we need some kind of reasonable maximum iteration count, really. Which would be impossible to say what it is. So this DT needs to be locked, right? So delta t equals, we'll lock it at 60 times per second. So what we kind of need, I mean, maybe this will always solve. I think what we do is we assume it's always going to solve. And then if it starts being a problem, we'll fix it later. Right. So we have now a structure. Do we have a structure? We have an array of world map rooms, right? That's basically the structure. So what we want is a world map, and then we want an array of world map rooms like that, and then we can put anything else we want about the world map in there. And then output is an array of world map rooms. So the output is going to be the world map, and output dot rooms dot rooms. And then this is static world map, world PAM, world map. And then this gets passed in there. And this is world map.rooms. So look everywhere that has rooms. Okay. Okay, that builds. Right. Brilliant. So it's saying crafting room has no connectors. Let's just check that all these connectors are there. Okay, so what I'm going to actually do, I might draw what room is what. So the world map rooms, and the rooms have a name. So, let's do get game HUD, draw label in world. The position is going to be the source room bounds dot center. The color will say, make it white. The border color will make black. Whoops. The string is going to be path, get file name without extension, source room name. Okay. Get game HUD identifier not found. Okay, so say temporary include game HUD. So this is going to draw the name of the room in the middle of the room, so we know what room we're in. Okay, so this is the fast travel room, and this links to the test room, and then this links to two rooms, the overlap room and the planting room. The planting room links to the chest. The chest links to the shop. The shop links to the data. The data links to the downloader. And the downloader links to crafting. Yeah, crafting doesn't link forward to any rooms. It's got a fast travel station in it, that's why. Right. So we need to put fast travel stations in now. Okay. So that's in here. So this is room to room. So we need a second stage where we just look at warp, where we just look at fast travel, fast travel kinds of warp. So we'll just go through them again. And we'll say if warp kind is not equal ewarp kind fast travel station, continue. And then what we want to do is we want to add in now a new type of connector. So we want ewarp kind there. And I think what we might do also, this is going to end up going in a header file where warp kind is forward declared, I think. Maybe. It's going to go in the world header file. Oh no, warp kind is there. So we can know what type of connector is what. So when we place it, we're just going to say .kind equals ewarp kind room to room. And then here, this is a lot simpler because we're not actually calculating the room here. We just say output dot rooms world map room index. So we need to find the world map room index, which we already know is here. So connector bounds dot in place connector bounds. And it's basically the same, except it's a different kind. It's the same for now. It's a fast travel station. All right. So we're just gonna say, so that's the room, and then we're gonna say if connector kind is room to room, we'll do that. Else, if connector dot kind equals ewarp kind fast travel station. So here's the thing about fast travel stations is they don't have destinations, they have multiple destinations. So there's something logically wrong there. So we'll leave them out. We definitely have a source. And then we're just going to draw these as like, we'll probably draw them as green. So fast travel stations are just green quads. Source warp bounds. So how do we calculate this? So it's the same. It is essentially the same. So it's here. Okay, so let's just see if they show up as green. Okay. Yeah, it's green. So that's the fast travel station. And then we're gonna go. We'll fast travel to the other room. It's not in the right place because we've shifted this room. Remember, we've shifted stuff about. Oh. You need to walk all the way over to it. I'm not calculating every frame now, so it's not going to update. I'm just calculating it once. So interestingly, these have all got little fast travel rooms in, which is absolutely incorrect. So it's drawn them in the same in every single room. Right then. Yeah. We have to filter by room as well. So this is actually if warp.source.room is not equal to room, continue. Then we actually have to do that as well here. Unchecked rooms. So it's the same bunch of checks. Ooh, the dest room. We're checking the destination room here. I think that's fine because this is not part of the recursive call. All right, so that's the green square there. Is correct. We're not drawing the green squares anywhere else. So let's head over to the crafting room, which is the destination of. It's got transporter room 2 in it. It's the destination of the fast travel stations 1. There it is. Okay. Is that in the right place? I thought it was a bit further down here. So let's do this. Hopefully this will make me do it every frame. If we just stop that being static. Killing frame rate. But at least we can fast travel transporter room T and have the world map update. It's killing frame rate because it's doing several. There it is. It is in the right place. It's killing frame rate because of the resolution of. It's having to push rooms apart over time, and that's taking like a long time, relatively speaking. And now it doesn't have to do that. I think that's why it's what's killing frame rate. There. It's this loop here. Let's ban this person. It's a bot. All right. I think that's what's killing frame rate. Is that we're doing this intersection thing all the time. Put that false. Again. Yeah, that frame rate's back up at 60 now because we're not checking. But anyway, you can see that's the right location. Oops. And then fast travel to transporter room 2, which is the crafting room. And that's in the right location. So we have all the fast travel markers now. So the fast travel markers, we're going to need a name for them, which we need to calculate. So what do we have at the moment? We have connector kind, fast travel station, and we've got this, and we've got its actual source location. So how do we calculate the name of the fast travel station? So if you go to fast travel controller, get a station by its ID, which is the kind. So it might be in world map actually. World map controller. Here we go. This is where we associate it with its position. So we can just get the name of the fast travel station by position. Oh no, these positions are what we need to result. So we need to get the name of the fast travel station some other way. So in the default world generator, we've got these fast travel regions. And what are they? Station and the points that it's in, and the bounds, and the location. So that's the room that it's in, and where it is. Okay, so what I'm going to do here we need to get the names of these fast travel stations. I'm just going to cache out the world and just see what's in there. So the world has in it these fast travel regions. The fast travel regions have locations in them with location IDs. The connector has a source connector in it. That's the position. So the connector has a room and a position in the room. So we just need to find the name. We just need to check the room with the world location and check the position is inside this bounds, I believe. Inside the bounds before it's been translated, which is at 0.69. Fast travel station in the fast travel room. So let's check that we're looking at the right room. Crafting room. Fast travel room at 0.9.5, 1.5, minus 9.5, 1.5, and the connector source is 6.9. It goes from -12 to -7. And the connector source is 6.9. That seems not correct. So when we actually generate this, source warp bounds is position plus offset. Yeah, so source bounds. So that source bounds should be relative to the room bounds. The room bounds is being offsetted. Because I think we're actually not doing it from the center. We're doing it from the bottom left corner. Which might still be fine. So we're going to go the fast travel region. I want to get the fast travel region based on a room and the location in that room, I believe. So let's try that. Where are we? So we've got it here for game location. Here. So we go through the room. The room's bounds intersect the position. So I might just have another one here. That is optref fast travel region. Get fast travel region. Const name a room. Const vec2 and the position in the room. Position, can't type today. Position. Which is actually just this. And then this can be location.room, location.position. Check that builds. It's called get fast travel region. Get fast travel region. Okay. So let's get the world, and then we're going to go if auto fast travel region equals world get fast travel region, connector dot source connector dot source room connector dot source dot center. And let's just see if we we can find it like that. So the coordinates might be off because the coordinate system for the rooms are from the center, and I don't know if the coordinate system from these are from the bottom left. So we might need to do a little offset there. We need to plus the bounds of the room over 2 to get it back into the center. Yeah, so we're not finding it. Let's have a look then. So 6, 9. So 0.69. So that's there, isn't it? 6, 9. So we need to maybe need to minus. We need to basically get it back into room space. So is this offset? Or we could just store it. Could store local here. Yeah. Let's store source local p, and then dest local p as well. So source local p is warp source position, and dest local p equals warp dest position. I need to do that here as well. No, just for the source. And then now this is connector source local p. All right, so let's see if we find it now. Yes. So the fast travel region is now fast travel station 1. So we can cache that. We can cast that to fast travel station kind. Fast travel station equals fast travel station kind fast travel region station and then we'll draw this label again. Except this is the localization of the fast travel station kind. We don't want to draw it in the bounds center. We want to draw it in source con bounds center. So this should just draw the name of the fast travel station. Bounds is not a member. It's not. This should just draw the name of the fast travel station inside that green rectangle. And then I think we have everything we need for the world map for now. We will add other things on probably. There we go. Transporter room 1. And then we'll just walk all the way over to the crafting room. Transporter room 2. There we go. So we've got the data structure ready now. We've got the world map data structure with all the information that we need. So we need to compile this into the game data. Somehow. So let's just check that in. And then we'll work on compiling it into the game data. Because like I said, this is going to be an offline process. It's going to get compiled into the game data. And assuming the world doesn't move as the player's playing the game, it will be fine. So what we also need is a transform, because we need to go from world space to world map space. We do need that. That's going to be quite complicated because we're shifting rooms around as well. So I think we don't go from world map to world space. We go from the world map room to the room space. So we do need to actually work out what this transform is. And I believe it's just the offset. Yeah, so we're moving here. It's not the offset. We have source local P, so we have a difference. So, excuse me. So, I just need to cough. So, we do have the difference because we have the local position, that's where it was, and then the new position. In the room though. So this is relative to the room, to the bottom corner of the room. So what I'm going to do is I'm just going to draw the player as a circle or something. Because this room, obviously, these rooms match up 1-to-1. When we scale it down, but this room doesn't match up 1-to-1. It's been shifted. So we need to calculate the shift, which is its actual location minus that. Okay, so we're going to draw the player position. Here, we'll draw it here. So auto player P equals get get game state dot get NPC position ENPC hero, and then all we're going to do is going to do canvas dot draw circle in world player P. The radius, I'll just say 1. Set count 16. Float color bit blue. So this is just going to draw where the player is, which should be directly on top of where we're drawing the hero, obviously. And then we need to shift it into world map space. All right. So let's have a look then. So we've got the room, and the room has a bounds. So we need to, so the actual translation so translation equals minus source room dot bounds dot center. So if we just plus translation onto that, not there, there. So it must be that. It must be plus. It must be just the center. So back to the center. Yeah, it's a hot load. It always takes ages to hot load. I think it's quicker just to stop and rebuild and start. Especially when you have large files. Yes, I know it is. Okay. Okay, so let's go over to the fast travel station. Okay. So there's also a flip round. I believe. And if we go to the room exit, it's right in X. Okay. Let's go to the game HUD and look how I do this in the radar. What do you call it? Is it the radar? What did I call it? No, let's have a look. A bit of a search. Not in there. Maybe I didn't call it radar. Minimap I called it. So I have this two minimap translation. Okay. No, I don't think that's going to help us. So I think I need to plus the height and then minus the Y. Maybe. So we'll plus the height. Oh. We plus nothing in X. We plus the height in Y. Okay. No, hang on a second. Yeah, that's what that is. So it's definitely right in X. So I need that minus that to get that distance. So I need to do that plus that minus that. So that minus that in Y. So we've got the... I want to get that vector from there to there. So that's that minus that. So it's... so we're just going to do value. No. I'm going to do value or 0. Right. And then we're going to say auto y offset equals that minus that. So that's the source room bounds minus player p dot. Yeah, I'm going to add the translation. Minus player p dot y. So that's that vector there, and then we need to get that plus the height plus that vector. So it's source room bounds dot y plus source room bounds dot height plus that vector. And then we have to put plus y offset. Well, plus vec2 0 y offset. Hang on, that's not right. Oops. We say 0. It's that minus that, maybe. Alright, why can't I do this? Let's try it again. The source room bounds. So what do we want to do? We want that distance, which is that minus that. That's that minus that. It's that minus that. Yeah. So the player P. So it's okay. So yeah. So it's the bounds top. So it's bounds Y plus bounds height minus player P. And then that gets that little vector there. There. And then if we take away that, let's just try this. Minus source room bounds dot height. Plus that distance there. No, that's not right. So let's stop shifting them. So let's comment this out. And then let's not even do the translation. Okay. And then let's now do the shift. Yeah. Let's quit the shift now. So let's try and build this up. Hang on a second. Let's just. Oops. We want to draw the player position. But the player position has to be relative to the room room center. Let's put that back. So I wonder if we can cache this out here. So we have the source bounds, which is the value of the room. We translated it by offset, so I think it's just this. So let's go world map room, transform. We'll just do transform equals source bounds dot translate. Transform is just minus offset. I think there's no member transform. World map room. Oh, I've forgotten a comma. And then let's transforming here. Let's make that just normal offset. And I think what we need to do is draw Jenny. The player's a bit confusing. So let's just draw Jenny. So this, we do need to know how far we are moving them. do we? Hang on. Let's see. Let's not have this transform thing. So transform is just a source room that bounds the XY. Surely. Go back to what we had before. Let's go back to doing it every frame. See, it's correct apart from the Y value. The X is correct. The Y is offset by some number. Okay. So even when the room is not shifted, okay, that is right, that one. That is wrong by Y. That is right. And that one is wrong. The X is right. The Y is wrong. They're the right. Wonder why that is wrong. And that is wrong on... No, that is right as well on X. Okay, so let's through this. So we're just drawing the source room bounds. I wonder if... No. Oops. So drawing that transform is minus 10 in X, 4 in Y. It says. Um, it's 3224. So what is the actual room bound of this room? Let's just, where were we? Let's do it. So we're saying that it's 3224. Get the room bounds. 3224, so it's minus 8, minus 16 to 32 24. Okay, so that's, it's not from 0, 0. It's not the center of the room. That's why. Okay, so we want to store the old room center. So we want vec2 local center. Wait. Let's have to bound. So dot local center. So this is auto local bounds. Source local bounds is that. Is source local bounds dot center. And it's that. So we want to. So this. Where are we? Minus source room dot local center. So either that way around or the other way around. Let's try that. If it works, I'm getting a coffee. Okay, that looks right. Yes. So now we're on the fast travel room in the world, and on the world map we're on the fast travel room. Okay, let's walk. So let's just check that this is right. So we'll walk through the world. Do this again. Yeah, that was confusing. But we've got it. So let's walk through the world. So that's just a one-to-one comparison. That's totally good. Okay, it seems to be all working. The rest of them are one-to-one comparisons. Because we're not shifting. So we'll go back to this one. And that is being shifted. And it's right, it's taken into account the shift. Okay. Brilliant. So what we might do, we might put in a transform here. So vec2 to room space. And that's just return v. Return v plus bounds.center minus local center. Is that what we have there? Plus bounds.center minus local center. So we'll get the player P. And then we're going to go world map dot source room to room space player P. This transforms from the world into the world map space. All right. And then let's make that static again, so I'm not doing it all the time. What we're going to do is we're going to get Jenny's position now. So auto Jenny lock equals get game state, get NPC location, the NPC ID Jenny, like that. And we're going to say if Jenny lock and Jenny lock room equals source room name. If Jenny's in the current room we're drawing, want to do this. And this is going to be Jenny lock position. And we'll draw her that colour. So she's going to draw Jenny on the world map. If it works. If this works, I'm having a coffee break. That was brain warping. So let's try and find her, wherever she is. She's nowhere. So Jenny's not been spawned yet. Let's spawn Jenny then. By going in. That's something we need to fix because let's go back to that room. Alright, so now I can see Jenny in the world map. She needs to be spawned all the time. Here she comes then. There we go. And then if we just get there before, well, we have to go all the way over. See it end up in that other room. We might miss her. We can wait for her to come back. There she is. She was there. She went back though. So we'll wait for her to come back. So now we can draw. So Jenny doesn't spawn actually until we enter the room that she's in. That's not actually how we want the game to work. Alright, so let's just wait for Jenny to turn up. So this is in the world map now. There she is. And she's going to walk along. And then she's going to walk back. Okay, great. So let's check that in. So now we've got everything we need to actually render the world map properly inside a UI. But first, coffee break. I'll be back in 2 minutes. Okay, fresh bucket of coffee. So now I have to start migrating this over into. So we need to save all this to disk. It's going to become part of the world data now. So let's do that. Right. So it's basically these three. So, well, actually, I won't. Yeah, that'll be fine. It'll be fine. I was gonna say I won't delete them, but it's fine. We'll just migrate it straight over. Okay. So this is where I save all the world data stuff. So we need to say how they're going to get saved. Connector bounds is going to get saved. So we want kind source dest source local p dest local p source room dest room, like that. And then a world map room. Map. So you should the name, the bounds. The local center, and the connector bounds. And then the world map itself. The rooms. And that's it. Might just call that room. I'll stick them in the source file. And then the world is going to have a world map in it. World dot map. Okay, check all this builds. Nope. Reader. Okay, check that builds. Nope. Map.rooms. Return that. Also return that. Reader.read. Oops. Reader.read. Okay, so that builds. Right. So then in the world map generator, on the default world generator, sorry. I think what we want is a generate world map. So static void generate world map, and then we'll just pass the world in. So generate world map, passing in the world, and then let's go to our old code that did that. Okay. So let's grab that. And the output being the world map and the game level. So we're going to have one world map game level, which means that the world map needs to be broken down further by game level. Let's get this working first, and then I'm just going to stick a note in here. I needed to do. How do I set the color of these? What's to do? Add rule. To do. Please fill out what the title is. To do. List title contains to do. Make to dos pink. What's this? These titles appear in both. How does this even work? This title is list title contains. The title snippets appear in both the is and contains fields. Should have one then. Oh, now it's crashed. Oh, let's try that again. To do. To do. Make it sky blue. Okay. You just save it. To do. There we go. So to do, we're just going to say world map needs to be broken, not split into levels. Okay. So the calculate the world map. Now does this build just as is? Get game canvas. So that is, I think, not even needed. Not needed. Okay. So now in generate world map, we need the current level. So this is done on the game level. And why do we need the level? We need the level to get the room bounds. That's all. Or to get multiple room bounds. So the room bounds need to be stored in the light game level. Where are we? Complete wrong file. Okay. So the light game level has in it so we need to store the room bounds. So we're going to say struct light level room rect bounds. W string view. W string name light level room. Name and bounds. And we want an array of those rooms. And then we want optref light level room get room const w string view name, and then this is gonna do rooms.find by name. Need to make that possible. Okay, and then in the default, was it the light game level generator? Content. Okay. So the content, does that have the flaws in it? Odd sprite. Sprite type. Okay, so how do we detect if it's a flaw? Append composite image groups. Group composite image groups. Composite image groups. How are these made? There it is. Content got get layers. Sprite windows. That's what it is. But basically, to get the bounds, we need to get all the sprite windows. And a sprite window has masks, and the masks have bounds, but the bounds are in pixel space. So I wonder. Yeah, it has to be stored in the world. So I wonder if we could store it in the level itself, but not all levels are in memory all the time. The world is in memory all the time. Because we're going to have to recreate the bounds of the rooms. Which is fine, it just means we're doing it a couple of times. So you've got the mask bounds, and this is over putting it into world space. Bounds, no, it's not. Maybe it's not. That looks like we're putting it into pixel space. Maybe it is world space. Okay. Let's have a look then. Here. So let's rebuild the world. What am I doing? Engine config. Let's rebuild the world. And just have a look and see what these sprite windows look like. If they are in pixels, if they are in world space, job done. Awesome. Calculate world map, identifier not found. Let's put that back in, because we do want to keep the old one so we can verify that the data is correct when we do the new one. All right. Oh, immediate. Whatever that is. Array subscript out of range somewhere. Oh, okay. Unfortunately, this means I need to rebuild it. I didn't build properly. Ugh. Unfortunate. Might take a couple of minutes. So we've got build rooms. So let's just do it here. Auto sprite windows equals content dot get sprite windows. And sprite windows have in them. So sprite windows is the flaws. They're called sprite windows because it's like an alpha mask. So it's just like a window into. It's a stupid name, really. And then they've got alpha masks. And the alpha masks have the bounds, right? Oops. For auto mask in sprite window. Alright, yeah. For auto window in content dot get sprite windows for auto mask in window dot masks, and then I want to see what they are. See what space the bounds is in, if it's in pixel space or world space. All right. Build. Okay. Oh. Okay, so it wasn't an error for that. It wasn't a build error. It is a build error. It's not me. Transporter room 1. Okay, maybe. Maybe it's because the dynamic initializer has not. Yeah, that's what it is. The dynamic initializer has not calculated the names yet. Okay, so that means this needs to have an initialize. It's a shame. Can't do that there. Okay. Get fast travel controller dot initialize. Okay. There we go. All right, good. Didn't crash. So the masks are in world space. Brilliant. I think they're in world space. They're integer world units. So to get the actual bounds for the room, we want bounding rect I, and then we just want to do bb.add mask.bounds translate. So this is offsetted by a position as well. We're not doing that in the level generator though, because we're saying that I think we do want to do that. We're saying that the floors are always in the base game level, and they're not made out of any prefab levels, but maybe that won't be true. Append composite image groups, which means dot translate position, and we'll fix that problem. And then here just needs to be bounds.mask. Well, yeah, we'll do that. And then the room yeah, so it's a similar thing actually. We're going to do pass it in like that, and then hang on, let's go back to the default level generator. So that returns a rectangle. In the right space. Yeah. Yeah. Got another BB here. I have to call this room bounds. Room bounds. And then we forward that along. Room bounds. And then this is bounding rect I room bounds, and we pass that along there, and then we want to do level rooms dot in place light level room, and that is made up of a name and a bounds. So this is just room files r.path and bm cast rect room bounds get rect. Okay. So we do this. So actually it does look like we're not adding on the position. So it does look like this needs to be a normal floating point rectangle. Which is fine. Let's do the cast here. So BM cast rect to erect. Got translate position. All right. So the room bound is valid. Minus 16 plus 16 minus 16 to 8. Chest room, I mean, that seems reasonable. All right. And then we have some kind of problem here with copying. So this is loading the world, right? Asset load the world. Num elements is enormous. So let's just go to the data. Where are we? Assets, data. Let's delete all the game data. And then let's just run all of it. This might take a while. I'll build all the fonts up now. So it was connector, kind, source, dest, local P, source room, dest room. And rooms. Okay. So let's go to the world generator and see if we get them. Because I deleted all the game data, it's having to rasterize all the fonts now. I forgot about that. It takes a while. Need to work on the font renderer, font rasterizer, because it's very slow. Okay. Right, so we generated the light level, and we have 10 rooms, and all the bounds. Test room bounds, yeah, so that's the one. The test 2 is the one that doesn't have a flaw in it, but they look reasonable. They look correct. And then, is it still crashing? What are we doing now? Image stuff. It is still crashing. Right. So why are we still crashing? Because this is enormous. So this is to do with when we load the world. And this is like multi-threaded. This is so num elements. So it's just read that straight in from the world file. Okay. Default world generator. Default world generator. Let's have a look then. So engine config, put the world version back down to 1. So the world has a map. Empty rooms. So I wonder if that actually is... We've got empty condition groups there. So let's have a look and see how this gets saved. Where are we? The map. We write the map. So we're saying write map. So the map rooms are empty. Array.getCount 0. So we're pushing in 0. And that's it. So at position 14490. It's saying there's 2 rooms in it. Confusing. There aren't, of course, 2 rooms in it. Okay. Empty. Hmm. Bit of a bug. Okay, it's probably because we're not defining the size of that. Let's try that. It might be true, it might not be. Rebuild the rooms. Nope, it's definitely not right. World map. Two rooms. Invalid. No, it's fine. So it's trying to fill it with two rooms. There aren't two rooms. Let's do a rebuild again. And then we'll have to just debug that. If the rebuild doesn't work, we'll have to actually check. So it's where it's writing it into, and that's where it's reading it from. Immediately before we were writing fast travel regions. Looks like the read cursor and the write cursor aren't the same location. We'll see. Okay. So that seems to... Ooh. Try that again. Did say we had empty rooms though. Okay. Okay, so we need to figure out where that's reading from. So it's reading from 13946. 13946. So let's just make a note of that. And then if we compile the world again, where does it write this to? One 4 4 8 2. So that is like way off, man. I mean, it could be off because there's probably... This buffer's probably going to get... Yeah, it probably is going to be off. Because there's probably a header going to be added to it. Okay. So do we read... So let's see where it starts going wrong. Immediately before we read the fast travel regions. So let's see what happens if we get them correct. We aren't even reading the fast travel regions. There. Alright. Probably aren't any. That's why. Okay, so this is us reading in the world. So trigger regions. 43 trigger regions. What's T? World condition group. T. World region. T. World map. Aha. Silly me. Must have deleted that by accident. Alright. Let's see if that works. Alright. So all we want is just to see if we load without crashing. Link. And then in the world generator, we can do this now because we can pass in the bounds. We have a way of getting the bounds. Like I might put the room local bounds in the world as well. I think we'll do that. Okay, so we didn't crash. Amazing. Right then, so what we're going to do now is we want to copy over into the world the room local, the rooms. So we'll just do world room. We'll do it here. Struct world room. And then all we want is say W string name rect bounds like that. And then we'll have an array and then just rooms. And then when we save a room, oops. And then it's just room name, room bounds. Because I imagine you will want to know things about rooms. And then we want an array of rooms. And then we're just going to put that here, world.rooms. Check that they are exactly the same. And then in the world generator, we can just copy it over. So for auto room in light level dot rooms, get rooms. Array light level room, get rooms, return the rooms. For each room, we're just going to say world rooms dot in place. Whoops. World room. Name equals room dot name. Dot bounds equals room dot bounds. And then, hello, are you alright? Yeah, good, thank you. Warm in here.
You alright for tea?
Yeah, I'm fine, thank you very much. We want rect get room bounds const w string view name const, and then it's just going to be rect result for auto room in rooms if room dot name equals name, return room bounds. No, yeah, that's fine. And then must return rect. All right, and then so now we can do this. We can get the room bounds. So let's open game state again. And go to this test function. Oh, lovely. Okay. So, yeah. What we need to do is we need to get the source bounds, source local bounds. So this is no longer a game level. This is the world. And this is world. Get room bounds. Room. And then this is world. Get room bounds, desk room. And this is the world. All right. So now so this is nice because this kind of solves, I believe, let me just open up the, because we're not working with levels now. That kind of automatically solves that. I mean, it's not even a thing anymore. It's not even a problem anymore. Okay, I might just archive that and delete it because it's not even a problem. Okay, great. Right then, so all we need to do now is we need to do to get like the first room. So this is the current location. So as long as the first room is connected to things, it will work. Well, we have this thing called checked rooms actually. So I think we can just go through all the rooms for auto room in world.rooms. Get rooms. World rooms. Okay, well I need to get rooms. How are you doing? Maths. Oh, nice one. Yeah. So get rooms. We need to calculate world map based on that room. So calculate world map. Room. World. Offset. Nothing yet. Checked rooms. World map. Because I think possibly this needs to be a member function. Just so it can be friends. No, does it? No, we'll just say get world map. I'm gonna need that anyway. World map. Get world map. Okay, world.get world map. Right. And then we need to do this splitting thing. So we want auto world map equals world.get world map. And that is basically it. Right, let's fix all these compile errors. Room dot aim. Okay. So let's have a look then. Let's check it. Right. Let's build the world again. Okay, so we can get rid of that. So this now should be building the world map and putting it into the world, which gets serialized to disk as an asset. which we can load up in the game and draw. Made a few changes. We're trying it for every room now, because rooms might not necessarily be connected to rooms. You might come into the room through the warp, the fast travel system, which is nice. So we'll end up with a bunch of... This is it, we'll end up with a bunch of maps now. So we need to kind of make that abstraction. So this is slightly... So the world map is actually a set of maps. The world map is a set of maps. We only make one currently. Right. So they've got the first room, which is the chest room. So we basically generate everything off the chest room now. Calculate world map. Aha. So this is world get warps. That is that world, that get world is the asset, it's the world asset. It's not loaded. That's the thing we're actually making. Right, again. Okay, try again. Okay. So the room has warps in it. Place one. Get a new offset. The destination room is the planting room. All right, so let's get back out of here. So you have a world map with 9 rooms in it. So we didn't include the room that has no floor. So it needs to have a floor to be on the world map. Right. And we didn't overflow the stack or anything. Let's try that again. The reason I say we didn't overflow the stack is because this is recursive and this is for every room. So basically what's going to happen here is that this first call will add all of these rooms in, and all the subsequent calls get earlied out, I believe. Better check that. So basically this can never get here again. So we end up here. Ooh. Oh, that's the one that has no floor. Right, good. Yeah, that's fine. That's good. Okay. Whoops. So let's just draw this. So it's not going to be centered around the fast travel room anymore. It's going to be centered around the chest room, just because that was the first room. Alright, so generate the world map. Whoops. What's my hotkey for? There it is. Hotkey for breakpoints. Okay, so this is the old one. This is the one that we generate in game state. So what I want to do now, whoops, is basically comment all this out. Comment the calculating of the world map out. And then just do auto world map equals get world dot get world map. Use the world map we just made. So it's centered around the chest. Then there's planting. This looks good. So this world map looks good. Let's spawn Jenny and see if it starts drawing Jenny in the right place. So where is Jenny? Jenny is over here in world map space. There she is. And she's going to fast travel to transporter room 2 now. Okay, that's awesome. So now we can get rid of all this. We can get rid of all this. Get rid of all this. And then get rid of all this. So now, all we're doing is loading the world map up from the world, which is an asset on disk, and drawing it. Alright, that's step 1 done. Now we need to draw it not on the main game canvas, but in the fast travel canvas, in here. But first I'm going to have a 2-minute break. Right then. So let's do this. So so let's just do this for now. So if we go to the game HUD, oh no, not game HUD, game menus, draw world map, canvas. Okay, so all this stuff we'll just leave there for now. So auto world map equals get world map, and the canvas is just the, we can't draw the label because that's a different canvas, so we just have to draw the room for now. Let's see how this looks like. Get world not found. Include world. So this is just going to draw the white rectangles of the rooms. No such thing as world. That's probably because it's in the engine itself. World. All right. Now, I don't know about scale. Might need to scale everything down. We'll see. Okay. There it is. Whoops. I think we'll scale everything down by a factor of 8 or something. So let's just divide it by 8 and just see what that looks like. So also what we need to do, it's centered around the chest at the moment. We need to center it just around the center of the world. Or the center of the level. Alright. Which is kind of, by coincidence, is roughly around the center of the level. Oh, here's a thing that it does look kind of, we're missing this room that goes above again. It's totally fine though. It's logically, look, you know, no problem. So we have our world map there now. Right, so it is by coincidence scaling around the middle room. Or centered around the middle room. Now, that's only coincidence. I think what we need to do is work. We need to get it generating from back in the fast travel room again. So that's the default world generator, right? Generate world map. So we're going to start. I'm going to force the start to the fast travel room. Start to be the fast travel room. Dot get room. There's no get room. Get rooms. Dot find. Where are we? So if you do the game.config, it's this. It's the name of the room. And then we just want to do, so we'll just make this temporary. And then we just want to do calculate world map based on the fast travel room. Is fast travel room name. Alright, so I have to do is this actually. So that'll calculate the room centered around the fast travel room. Calculate the world map centered around the fast travel room. I need to rebuild the world. All right. So here we are again, calculated around the fast travel room. So there it is. Now, I think we... Is it a problem? Like, so we're definitely going to want to center the room around the player anyway. The world map around the player. If we center the rooms, the world map around some arbitrary origin, it just makes it more complicated. It might make it more complicated. So what we need to do is, what we'll do is we will leave it like that for now, and then we'll go to game menus and we'll set the camera to be centered around the player. In room space. In world map space. So so player P, well, hero P equals get game state dot get NPC position hero. Okay, it's in the room actually. If so it's get NPC location because it's source room to room space hero P position. Okay, so we're going to say if hero P and hero P room equals source room dot name. Auto this is hero lock actually. Hero P equals source room to room map space hero lock position, and then we want to do want to draw it, draw a circle in world hero P, draw it blue, segment count 16 again. And what we want to do is we want to go world map camera dot position is hero P. Let's see what that looks like. Okay, I'm not drawing the room anymore. Okay, so we're scaling that, so let's not scale that anymore. Ugh. Cancel. Let's not have it more complicated than it needs to be. Whoops. All right, so we're not moving the hero now. We're not moving the hero because we're on a menu. Which totally makes sense. That's exactly what we want to do. That's exactly not what we want to do. We don't want to walk the player around the map, around the world map. We just want to see if it's drawn in the right place. So we know that this blue circle is right. It's like halfway up. Yeah. So that is the player on the world map. I think we're just drawing them in screen space at 16. So pixels to world at 8, sorry. Is that right? I think that's right. Oh, draw circle in world. It doesn't take a transform like that. We should make it do that. Like these. Okay. So it's a coordinate transform. Draw circle in world. Is that right? Okay. Where are we then? We're in here. So now we can do pixels to world 8. No, we can. Center transform seg count. Oh, because pixels to world is oh, that is right. It's a vector. Say .x. That's totally fine. Okay. So we're drawing the hero in the right place. So let's run up to the we're not centering the map around the hero, which we definitely want to do. But we only want to do that at the beginning. When we open this menu. So, okay, let's just check that we're working first. Because we want to be able to move the map around with the mouse after. We don't want to keep constantly setting the location of the camera every single frame to the hero's position. No, there now. What is the problem here? Term does not evaluate to a function taking one argument. Apparently. So we are just doing it here. Where is it? Center, coordinate transform, seg count, color, Z. Yeah. We can do float operator. No, that's fine. All right, that works. Okay. Okay. Who trying to call this? All right, so it's when it's an integer. um. So I think we just need to do requires not standard is arithmetic coordinate transform chord transform. So let's see if that allows that to build. Does not. Scalar. Okay, that's worked. Right then, so we'll get the scale side. Well, no, we'll get it opening in the right place side, and then we'll get the scale side. So, okay, we need to override on enter like that, and when we enter this, it's not enter, it's on enter. When we enter this, fast travel menu on enter, we're going to say world map camera dot position equals okay, so auto world map equals get world map for auto room in world map get rooms so maybe we should extend world map a bit actually. So world map, get world map room for NPC, get world room for NPC. So optref world room, get world room for NPC, enpc id. So this is for ID. So we're going to say for entity. Like that. Get world room for entity. No, it's not a world room. It's a world map room. Get world map room for entity. So this is going to go for auto room in world map on map rooms. Yeah, auto eloc equals get game, get entity location ID. If eloc, go through the rooms and we're going to say if room dot name equals eloc room return room. Object should not be bound to an R value reference. Okay, auto room. Okay, so now in the game menus we can go if auto room equals get world map room for entity enpc id hero, and this has to be standard 2 underlying enpc id hero. World map camera auto, so yeah, world map camera position equals room to room space. We need the game's position. We need the hero's position. Hero P equals get game state. Got get NPC position. hero. Value or 0. Maybe the playable character actually. Playable character. Because then it will work for any character. To room space hero P, character P. So that'll basically center the world map. When the menu opens, it'll center the world map on the playable character, in theory. Which means that the hero is always at this. Well, we'll get to that in a bit. There we go. We can still move it. So I would suggest that's still a little bit big. So we need to do some scaling. So this is for the playable character now. However, everything else is for hero. You know, the ready states. So maybe we'll keep it at hero. It's only the hero that's going to be able to access the fast travel menu. And we'll change it if it's not. We'll make it more complicated when it needs to be more complicated. Okay. So let's go about the scale. So to make this scale right here, we have to go divide by 8. Divide by 8, right? But we don't want to do that. We want the code to be as it was. So we want the scale to be happening automatically. There we go. So we can see there that it opened in the wrong place as well because of the scale. That's why we want it to be happening automatically, because we forgot to scale it there. So we just want to set scale, basically. Which means these kind of essentially have to become private. Or at least that does. So something like this. Float scale equals 1. Then we just want like rect get scaled bounds. I think that's also a const. And this is just bounds divided by scale. Ugh. Okay, we'll just let it be infinity. And then this is divided by scale. And then this is room. Get scale bounds. It's not scale though, is it? It's zoom. So when we open this again, we just want to say probably set world map scale or zoom. Zoom's also the wrong word. It's like an inverse scale. All right. So this is map.zoom. Yeah, for auto room in map.rooms. Ah. I'll do it here. Do you want to set it globally? Probably do want to set it globally on the map actually. So that means a zoom. I'll do it here. Keep it simple. Room.zoom equals zoom. Okay, so we want to do get world, set zoom, set world map zoom to 8. It's actually probably the inverse. Get zoom bounds. Get zoom bounds. Get zoomed bounds. Okay. There we go. That is the correct hero location in the map. To prove that, we'll go to the other fast travel station. And there we go. Okay. So I think now in game state we can stop doing this altogether. Do we have any temporary includes? The game HUD, we can get rid of that. So we have a world map. We're drawing the player in the right place. Now I just need to draw everything else we want, which at the moment is just the fast travel stations from this point of view. The transporter rooms. So let's take out fast travel control. Let's take out the transporter rooms that don't actually have locations in the world, and then in the world map controller, so we could actually set the scale and stuff through here. Yeah, I think we should do that. We should set the zoom and do everything through this controller. It will change to do that in a minute. So the position we don't know at the beginning. What we need to do now is set the positions of the fast travel stations. So it's set to 0, 0. So we need to set it so we need an initialize basically. And this initialize is going to set all of the fast travel locations in the map. Game state initialize, get world map initialize. Probably need to include that. Yep. So when we initialize the world map controller now, we need to get the world map location. So for auto lock in locations, so let's get the fast travel controller. Get fast travel controller, and then we need to do if auto station equals fc dot get station lock ID, right? So if there's get a fast travel controller, we have the station dot position, right? And that no, we have the location dot position needs to be set. So we need to get get world map, get world. And then get world map. So get the world map. And then we want to do, so it's a different type of map. World map. So the world map in it has these connectors, and these connectors have kinds. Okay. Let's just go back to game state a second. Prematurely deleted. So it's this. Okay, so let's just get the world. We know we need the world. Can we get the world? We cannot, so let's just get the world. And then we need to get the connector. So we want to go auto world map equals world, get world map. And then for auto room in world map rooms, for auto connector in room dot connector bounds it's not if, for call it connector bounds. It's just a probably just do a world room connector. And then connectors. Okay. world map controller. So this is room.connectors. If connector.kind is not equal to ewarp kind fast travel station, continue. And then we're just here now. Not drawing anything. Okay, so we have the fast travel station. So we need to go. We need to get the locations. World map location type. So for auto lock in locations, if not lock, oh no, if lock type is not equal to e world map location type fast travel station, continue. And then we need to go if, so we're going to go auto source ID equals get fast travel station ID, fast travel station. I'm going to say if lock.id is not equal to source ID, continue. So we don't need to check that it's a fast travel station. And then we just, oh well, have it right there. If it equals the source ID, then lock.position equals connector source dot translate connector source room bounds XY. Okay, so auto source room equals connector source source room. That's fine. Ah. So that that's wrong, isn't it? What's going on here? Connector.source source room bounds XY. So we need to draw anything. Don't need to double declare world. Center. All right. Let's see. So can we find locations by ID? Yeah. So we can say if auto lock equals locations find false ID or lock ID. Okay. So the world has not been initialized yet. It requires the world. Game state. I would have thought. So it probably has to. Yeah. So I think this isn't an initialize, it's a launch function. And this is called launch. Because a launch function gets launched every time the game is launched. From fast travel or from saves or at the beginning of the game. And then, so it's not actually allocating any memory. Ooh, what's the problem there? Why don't you like that? Well, I don't actually need to do that. So this is not actually pushing any, it's just setting locations. So that's fine, but hopefully that means the world is there by the time we're launching the game. Right. So we don't see it. Let's try that again then. Ah, it's because it's not that. It's No, I think that is right. That is right. Okay. So, game menus. We need to draw them now. Location position. Ooh. That's in the map space. Now. This is room dot to room space. Now that's not going to work. Because we're scaling the okay. So this is just us filtering out the station, P screen, location, position. So this is where we need to do the translation. So the map has a location, and location has an ID. Does the location have... It's a type and a position. All right, so when we set the world map zoom, it has to reset all the locations. So I'll tell you what we'll do. We'll just get it working for zoom equals 1. And then here, this needs to be room to room space. Still not there though. So let's just do canvas. So that location position seems very wrong. So let's not do that. And then in the game menu, let's just do canvas.draw circle in world. Location dot position pixels to world 8 16 bright green. Let's just comment all this out for now. All right. Still not there. Why is it not there? What's this location? Transporter room to fast travel station. Transporter room 2. Ah. That's the death station. So it says it's minus 236. She's very far away. Right. So it's minus 19. It seems reasonable. And then minus 20. Okay, so I think that is relative. Don't know. So that's the bounds. And the connectors has a fast travel station. It has two of the same connector in. I think they're identical. You need to sort that out. That's its local position. That's its source position. Relative to XY. So its source plus room bounds to XY. So that is right. Okay, so by the time we get to the menu, so the location of the position, Transporter room 1. Transporter room 2. It's gone to 236. Death stairs. Oh, because this is a destination. Okay. So let's go all the way over to the destination. All the way over here. There it is. Okay, so do we want to draw the source station as well? The source station is where the station that we're on. Okay, that's good. That works fine then. So what that means is we need to be able to do this every time we set the scale. Okay. So what we want is we want void set zoom scale. Set so the bigger the numbers, I mean the more zoomed in it is, more zoomed out it is. Let's just set zoom. Float zoom. So so what we need is we need auto world equals get world, and then we want world set zoom, world map zoom, zoom, and then we need to get all, need to do this. And that needs to be divided by zoom. I'm going to say if zoom equals 0, zoom equals 1, like that. And then on launch, we're just going to go set zoom to 1 to 8. Well, 1. Like this. And then in the game menus, when we actually open the game menu, we want to say get world map controller dot set zoom to be 8. Like that. So that zooms the world map in by 8. So this needs to include the world, which it does. So what's the problem here? Redefinition. There we go. So that's a current location. So it's fast travel transporter room 2. Well, let's look at our map. Fast travel transporter room 2. And then we can locate our map. Fast travel transporter in one. Awesome. So let's put back in tapping it on the map. Go. So there we have it. So I'm going to draw the connectors because it's a bit confusing without the connectors. So for auto con in source room dot connectors canvas draw line in world con source local p con dot source center on dot dist center block color, and we'll just say John pink in max. They may need to be scaled actually. I think you do. We'll see. Yeah, need to get scaled. So to scale things, it's wrong. Connector. So we have, so it's just divided by source room dot scale dot zoom. We'll just do that now. We won't put any actual proper mechanism in for scaling them because I don't really know if we're going to draw them. Okay. Ooh, that's not right though, is it? Ah, because I think it's connections. I'm all right, thank you. How did we draw the connectors before? Got to translate it by the room bounds. Yes. So auto p0 equals con dot source dot translate source room bounds xy center auto q1 equals con dot dest dot translate by the dest room bounds. Hang on a second. Source room dest. Was it con dest dot bounds dot xy center. No, that's not right. It's the dest room bounds. How do we do that? Dest room. So we find the dest room. So it might actually be nicer to put the dest room bounds in the connector. So like the source room bounds, dest room bounds. Ooh, no, because we're moving them. So we need to get the dest room. Where are we? Yeah, menus. So we need to get the dest room. If auto dest room equals world map dot rooms dot find con dest room. Dest room dot bounds dot xy. Right. That build. Bounds is not a member of this. Because that is optional. And so now we just need to do canvas, draw line in world. P0, P1, float color 101 in max. And that'll just draw the room connectors, hopefully. Once it's built. and then we need to scale it. So that's just divided by source room zoom by desk room zoom. All right, there we go. So there are all the connectors. Connect each room to each room. All right. So I think let's just another transporter room in the world with the editor. Well, or we could draw what room is what. Let's draw what room is what first. So this is auto room bounds. Source room bounds. So let's draw source room bounds dot. Well, hang on a second. We want to probably draw it in the bottom corner. So bottom left align text. Source room name. Dot bottom left. Okay, so that should draw the room name in the bottom left corner of each room. Okay, but not the full room name. So auto room name equals path. Get file name without extension. Ooh. There we go. So let's put a fast travel station in chest, and we'll see if it just updates. So let's open the chest room. Well, we need to make a fast travel station first. in the code. Fast travel controller, transporter room 3, right? Then the world map controller. We need to have another world map location. So I think we can automate this as well. We'll get work on that in a second. Fast travel station. We'll automate this. Automate adding new fast travel stations. So we'll come back to that. And then we'll, in the editor, we'll try and put in transporter room 3. So we'll open this up, right? So we're going to put transporter room 3 in the chest room, right? So right now I've put it as 000, right? Which is wrong. So open rooms, prototypes, chest. So we're going to put in down here an event, game event, broadcast fast travel station, transporter room 3, trigger ID is this. And the condition is, it's a trigger condition that we are inside this trigger. So that isn't, so let's launch that. And if we open up here, there it is in transporter room 3. Mint. Try that again. Fast travel to it. So let's actually put it up there for a second. Was there a slight bug as well where the hero didn't spawn in? Or was I seeing things? Maybe seeing things. There it is, from transporter room 3. Okay, cool. So what we're going to do now is we are going to automate this. So it's going to be locations. Reset are empty. And then for auto, well, for F in enum count, E fast travel station kind. It's for 2 because we don't want to include the known one. We're just going to go locations dot in place. E fast travel. What is it called? World map location. Well, I might actually do a constructor for this. type ID, ID, type, type, like that. Send that into the source. And then we can just say emplace, get fast travel station ID. Well, auto kind equals e fast travel station kind f. Kind fast travel. Right. So that will just mean that we'll automatically get it. So that can be default now. Awesome. Right then, so that's awesome. So I might, just for completeness sake, put in the draw the NPCs on the world map. Although do we want to do that? Because this is the fast travel world map, we probably just want to see where the other fast travel stations are. We'll probably move that up a bit because I can't read it. Four. So that kind of means, I think, that the world map is fully implemented as far as I want to take it right now. Whoops, what's wrong? -4. If you look there as well, the scissor's not quite right. Interesting, we'll have to fix that scissor. I'll do that now. So I'll have a 2-minute break and then I'll fix that scissor problem. Okay, so we'll have a quick look at this scissor problem. So if you spawn the world map, you can see that these lines are getting drawn over the top of the border, because the scissors actually set where this border is, so it's this bounds here, which is kind of wrong. This bounds, the white line appears. Okay, so why is that? So if we just do scissor.inflate by 8. See what happens there. That's not right, that's not right. Oh, I know why. It's because these are int max. Yeah. Okay. They've been drawn after we've set the scissor, after we've reset the scissor. So we have to do it in Z order quad. So circle outline, I believe, is lines. So that's Z order line. And then we want Z order quad for the rest. For these, where are we? So that's Z order quad, Z order line, Z order line. Let's see if that fixes it. Okay. There we go. Apart from here. Oh, that's because, yeah, that is a strange one. I wonder if it's cause those, yeah, the, where we draw the actual grid. Where's the grid? Draw world grid. It's here. Oh, no, it's not. So it's quad. So those quads as well are not obeying the scissor. These lines down here, for some reason. we do the background, and then we're going to do draw world grid at the quad Z order. Okay, I'm going to pix that. I'm going to have to finish soon. But I'll just look at it in pix and see what the scissor rectangle is. Okay, world location, canvas. So it's these. Scissorect. Scissorect is slightly off. Interesting. Where is it? It is slightly off by 8 pixels. How do I find out what the scissor is? Pipeline state. There's nothing there. I would have thought it would have been in there. Don't think so. Okay, so it is a little bit too big, but then those. Anyway, doesn't matter, we'll fix that tomorrow. It's not even showing me where I'm setting the scissors. Scissorect. Definitely off by a few pixels. All right. We did quite a lot of work today. Finally got the world map rendering in the UI. Then we can add transporter rooms and they automatically appear on the world map, and we can click them and we can go to them. Right, so I'm back here tomorrow morning at 9:30 GMT, and I'll